All right, let's dive in. Today, we're pulling back the curtain on a piece of technology that is, well, pretty much everywhere: machine learning. You hear the term thrown around all the time, right? But what does it actually mean for machine to learn? I mean, just think about this for a second. Your email inbox. How is it so good at filtering out all that junk? Nobody sat down and programmed it with a giant list of every possible spam word. The answer? It learned. It learned to spot spam all on its own. And that, right there, is the powerful idea at the very core of everything we're going to talk about today. So, here's how we're going to tackle this. First, we'll get into the big idea: learning without a rulebook. Then we'll look at the three main ways machines actually do this: with a supervisor, completely on their own, and just by trial and error. After that, we'll see where this stuff pops up in your world. And finally, we'll touch on the big challenges and what's just around the corner. Okay, so let's start with the fundamental shift here. For, decades, programming meant giving a computer a super strict set of instructions for every single possibility. Machine learning basically just throws that whole rulebook out the window. It's all about teaching computers to learn from experience, kind of like we do. So, this is the crucial part. Instead of writing a million lines of code like, if it has pointy ears, and it has whiskers, and a long tail, then it might be a cat, we just showed the computer thousands and thousands of cat pictures. The algorithm looks at all that data and starts to figure out the patterns, the very essence of what makes a cat, all by itself. It's learning from the data, not from our explicit instructions. And you might think machine learning is this brand new thing, but its roots actually go way, way back to the 1950s. The basic ideas have been around forever. So what changed? Well, the 2010s brought two absolute game changers. First, a ridiculous explosion of data from the internet, and second, the insane computing power we needed to actually process it all. That combination is what turned these old academic ideas into the world-changing force we see today. Okay, so that brings us to the first and honestly the most common way that machines learn. It's called supervised learning, and most of the machine learning you interact with every day probably falls into this bucket. The best way to think about this is like studying for a test with flashcards. You've got the question on one side, and you've got the right answer on the back. You just keep drilling, going through thousands of these cards until you can look at a question and pretty much nail the answer every single time. So here's how that actually works. We feed the machine labeled data. That's data where we already know the right answer. For our spam filter, that means showing it tons of emails that are already marked spam or not spam. It chews on that, learns the patterns, and then it can classify a brand new email. We call that classification. Or you could give it data on thousands of houses, all their features, and what they actually sold for. It learns from that to predict a price for a new house, and that's called regression. Okay, but what if you don't have that answer key? What if all you have is just a massive, messy pile of information with no labels? Well, that's where our second type of learning comes in: unsupervised learning. For this one, I want you to picture a detective walking onto a chaotic crime scene. They have no suspects, no leads, nothing. Their job isn't to prove who did it, it's to sift through all the messy evidence and find hidden patterns, connections, or groups that nobody even knew existed. So the machine gets a whole bunch of unlabeled data, and its only job is to find the hidden structure inside. A classic example is something called clustering. A company could feed an algorithm all of its customer data. The machine might then, all on its own, discover these distinct groups or clusters, like weekend bargain hunters or late-night snack buyers, without ever being told what to look for. It's an amazing way to find hidden segments in a market. And now for our final and maybe the most dynamic way of learning. This one isn't about labeled data or finding hidden patterns. This is all about learning from action and consequence. This is reinforcement learning. The metaphor here is just perfect. It's a coach training an athlete. The coach doesn't hand the athlete a textbook on how to play the game. Nope, the athlete just plays. They try different things, and they get constant feedback. A good move gets a reward, a great job. A bad move gets a penalty. And over time, the athlete just naturally learns the best strategy to win. So in this model, the machine, which we call an agent, learns by doing. It takes an action in some environment. Think of a chess program making a move. If that move puts it in a better position, it gets a little digital reward. If the move is bad, it gets a penalty. After playing millions and millions of games against itself, it just discovers the best strategies to maximize its rewards. It masters the game without ever being taught what a good move even is. So let's just quickly pull those three ideas together. You've got supervised learning, which uses labeled data to make predictions. You've got unsupervised learning, which uses unlabeled data to discover hidden patterns. And you have reinforcement learning, which uses feedback from its own actions to figure out the best decisions. Three totally different approaches for three totally different goals. Okay, so that's all the theory. Now let's bring it back to the real world. You might actually be surprised how often you are interacting with these different types of machine learning, probably every single day. You know when your bank sends you that text message about a suspicious transaction on your card? That is supervised learning in action. The model has been trained on millions of past transactions, all neatly labeled as either legit or fraud. It learned the pattern so it can spot a problem in real time and, protect your money. Ever feel like your favorite streaming service just gets you? Like it knows exactly what you want to watch next? Well, that's a classic case of unsupervised learning. Its algorithms look at your viewing habits and then cluster you with millions of other people who have similar tastes. The movies it suggests are just the things that people in your cluster also loved. Now, self-driving cars are a really cool mix of all these techniques, but reinforcement learning is absolutely crucial. In simulations, the car's AI drives for millions and millions of virtual miles. It gets rewarded for safe moves, like braking smoothly, and it gets penalized for mistakes. It learns the best way to drive through this endless cycle of trial and error, getting it ready for the chaos of a real road. Now, as powerful as all this is, it's not magic. Machine learning comes with some pretty big challenges, and the whole field is working like crazy to solve them. This question gets to the very heart of one of the biggest problems in AI today, interpretability. See, many of the most powerful models are what we call black boxes. They can give you a stunningly accurate answer, but they can't tell you how they got there. And that's a huge problem when that decision affects someone's life, like, say, a loan application. So we're often stuck with this really difficult trade-off. On one hand, you have a simple model with clear rules that we can easily understand and check. On the other, you have a super complex model, a black box, that's way more accurate, but its decision-making process is so tangled that no human can really follow it. It forces a choice between performance and transparency. And because of this whole black box problem, a massive area of research right now is focused on something called explainable AI, or XAI. The goal here is simple: to build models that are not only powerful and accurate, but also transparent. We want systems that can actually justify their decisions, and that's absolutely critical if we're going to trust them. And that really brings us to our final thought. We've seen that machine learning is all about teaching computers to learn from data. But what is data? It's just a reflection of our world, the things we choose to record. So as these systems get more and more woven into our society, the really important question isn't just how they learn, but what are we fundamentally teaching them? The answer to that is going to shape all of our futures.